A glimpse of alien lights, the discovery that changed everything. The control room at NASA's Goddard Space Flight Center was a hive of quiet anticipation. Screens glowed with streams of data, and the air hummed with the software computers processing signals from a telescope a million miles away. Dr. Elena Martinez, lead astronomer on the James Webb Space Telescope, JWST, exoplanet observation team, leaned forward in her chair, her eyes fixed on the display. For weeks, the team had been analyzing infrared data from Proxima Centauri b, the closest known exoplanet to Earth, just 4 light-years away. But tonight, something extraordinary was unfolding. "Elena, you're going to want to see this," called Dr. Raj Patel, her colleague, his voice tight with excitement. He pointed to a graph on his monitor, where a series of rhythmic pulses spiked above the baseline noise. The data wasn't random. It had a pattern, a cadence that seemed almost deliberate. Elena's heart skipped a beat. She adjusted her glasses and leaned closer, her mind racing through possibilities. Could it be a glitch, a stellar flare, or something else entirely? The James Webb Space Telescope, humanity's most advanced eye into the cosmos, had been trained on Proxima Centauri b for months, capturing faint infrared signals from the distant world. Unlike most rocky exoplanets, which absorb sunlight and radiate it back as infrared, Proxima b was behaving strangely. Its host star, Proxima Centauri, a red dwarf, bathed the planet in intense energy, creating dramatic temperature swings between its scorching days and frigid nights. But these pulses weren't just thermal emissions. They were sharp, concentrated, and eerily consistent, almost like the glow of city lights flickering on a planet's dark side. Elena's thoughts spiraled. City lights. The idea was audacious, almost absurd. For centuries, humanity had dreamed of finding life beyond Earth, but the notion of detecting an alien metropolis was the stuff of science fiction. Yet here it was, staring her in the face, data that suggested something artificial, something alive, on a world 4 light-years away. She turned to Raj, her voice barely above a whisper. "Are we sure this is an error?" "We've triple-checked the calibration," Raj replied, his dark eyes gleaming with a mix of disbelief and exhilaration. "The signal's real. It's coming from Proxima b's night side, in a frequency range that doesn't match natural stellar emissions. It's like nothing we've ever seen." The room seemed to hold its breath as the team huddled around the monitors. The implications were staggering. If these were indeed artificial lights, they could be the first evidence of an advanced civilization, a discovery that would rewrite humanity's place in the universe. The telescope that saw the impossible. The James Webb Space Telescope was humanity's crown jewel, a marvel of engineering orbiting 1,000,000 miles from Earth at the second Lagrange point, where it floated in perfect balance between the pull of the sun and Earth. Its golden, honeycomb-like mirror, spanning over 21 feet, was designed to capture the faintest whispers of light from the farthest reaches of the cosmos. Unlike its predecessor, the Hubble Space Telescope, Webb specialized in infrared wavelengths, allowing it to peer through cosmic dust and detect the heat signatures of distant worlds. Proxima Centauri b had been a prime target since Webb's launch in 2021. As the closest exoplanet to our solar system, orbiting a star just 4.24 light-years away, it was a tantalizing candidate for study. The planet, roughly Earth-size, was locked in a tight orbit around Proxima Centauri, completing a full cycle every 11.2 Earth days. Its proximity to the star meant one side was perpetually scorched, while the other lay in eternal darkness, a stark contrast that made it a challenging but fascinating subject. Elena had spent years studying exoplanets, but Proxima b was special. Its orbit placed it in the so-called habitable zone, where liquid water might exist, depending on its atmosphere. Scientists had long speculated about the planet's potential to host life, but the lack of direct evidence had kept those discussions firmly in the realm of theory. Until now, the pulses of light detected by Webb were unlike anything natural. Stars emitted broad spectra of light, but these signals were narrow, precise, and pulsed in a way that suggested intent. Elena couldn't shake the image that kept forming in her mind. A sprawling alien city, its lights twinkling in the cosmic night, waiting for someone to notice. A cosmic puzzle unfolds. The discovery sent shock waves through the scientific community. Within hours, Elaine and her team were on a secure video call with astronomers from around the world, including Dr. David Kipping from Columbia University, a renowned expert on exoplanets. Kipping's face appeared on the screen, his usual calm demeanor replaced by a barely contained excitement. "This is unprecedented," Kipping said, running a hand through his hair. "Proxima B's behavior doesn't align with any known natural phenomena. The light signatures are too structured, too rhythmic. If I didn't know better, I'd say we're looking at something artificial." "But how?" Elena asked. "Even if this is artificial light, how could it be bright enough for Webb to detect from 4 light years away?" Kipping leaned forward, his eyes narrowing. "It's possible the civilization is advanced enough to produce intense, focused light sources. Think megastructures or energy-intensive technology. Webb's sensitivity to infrared is key here. It's picking up signals that other telescopes would miss, especially on the planet's night side, where natural light from the star isn't drowning it out." The team spent days analyzing the data, ruling out every possible natural explanation. Stellar flares? Too erratic. Atmospheric scattering? Too diffuse. Instrument error? Impossible. The data was consistent across multiple observations. The more they studied, the stronger the case became. These were artificial lights, potentially from a civilization on Proxima Centauri b, a planet unlike any other. Proxima Centauri b was a world of extremes. Tidally locked to its star, one side baked under relentless radiation, while the other froze in perpetual darkness. The temperature difference could be hundreds of degrees, creating a planet of stark contrasts. If it had an atmosphere, it might moderate these extremes, trapping heat and distributing it across the surface. But without one, the day side would be a scorching desert, and the night side an icy wasteland. Webb's infrared capabilities allowed scientists to study the planet's thermal emissions, offering clues about its atmosphere. The telescope spectrographs could analyze the light passing through the planet's atmosphere, searching for chemical signatures like water vapor, methane, or carbon dioxide, molecules that might indicate life. Detecting free oxygen, a hallmark of biological activity, was trickier, as Webb wasn't optimized for it. But ozone, a byproduct of oxygen, was within its reach, and the team planned to look for it in future observations. What made Proxima b so intriguing was its dynamic relationship with its star. Proxima Centauri was a red dwarf, smaller and cooler than the sun, but prone to violent flares that could strip a planet's atmosphere. Yet, if Proxima b had a robust magnetic field or a thick atmosphere, it might have withstood these assaults, preserving conditions suitable for life. The lights detected. The weight of discovery. As the news spread, the world buzzed with speculation. Social media exploded with hashtags like #AlienLights and #ProximaCity. Artists rendered glowing metropolises on alien landscapes, while pundits debated the implications for science, religion, and humanity's future. At NASA, Elena and her team faced a deluge of questions from the press and their peers. Were these really city lights? Could they be something else? And if they were artificial, what did that mean for humanity? Elena felt the weight of the moment. This wasn't just a scientific discovery. It was a cultural and philosophical earthquake. For centuries, humans had gazed at the stars, wondering if they were alone. Now, for the first time, there was a hint that they weren't. But with that hint came uncertainty. What kind of civilization could produce such lights? Were they friendly, hostile, or simply indifferent, unaware of the tiny blue planet, observing them from across the void? The team knew they needed more data. Webb's observations were groundbreaking, but they were just the beginning. The telescope's orbit allowed it to observe Proxima b's day-night cycles every 11.2 days, providing opportunities to confirm the signals and study the planet's atmosphere in greater detail. If the lights were real, they might be accompanied by other signatures of civilization, perhaps radio signals or atmospheric pollutants like those produced by industrial activity on Earth. The next steps, the discovery, prompted a flurry of planning. NASA scheduled additional observation time for Webb, prioritizing Proxima b's night side to capture more of the mysterious light pulses. Meanwhile, ground-based observatories like the upcoming Extremely Large Telescope, ELT, set to begin operations in 2028, were preparing to complement Webb's findings. The YLT, with its massive 39-meter mirror, will provide unprecedented resolution, allowing scientists to probe the planet's atmosphere for biosignatures like methane or water vapor. But the ultimate dream was to develop telescopes capable of directly imaging exoplanets. Current technology, even Webb's, couldn't resolve surface details from 4 light-years away. Future missions, however, were already in the works. Concepts like the Starshade, a massive flower-shaped spacecraft designed to block starlight, promised to revolutionize exoplanet observation. By flying tens of thousands of kilometers ahead of a telescope, the Starshade would create a shadow, allowing the telescope to capture the faint light reflected by a planet's surface. Another innovation, the coronagraph, could be integrated into future telescopes to suppress starlight internally. These technologies require precision on an almost unimaginable scale, aligning a star shade to within millimeters over vast distances, or calibrating a coronagraph to filter out a star's blinding glare. But the payoff would be worth it. Direct images of exoplanets, potentially revealing surface features, oceans, or even the outlines of alien cities. A glimpse into the past. As Elena stood outside the Goddard facility one crisp evening, staring at the stars, she couldn't help but feel a sense of cosmic vertigo. The light from Proxima Centauri B had taken 4.24 years to reach Earth, meaning the signals they were seeing now were a snapshot of the planet's past. Whatever civilization might exist there was thriving, or had thrived, over 4 years ago. Were those lights still shining? Had the civilization that built them advanced further, or had it faded into history? The thought was both humbling and exhilarating. Each observation was a journey into the past, a cosmic time machine revealing the universe as it once was. And with each new dataset, humanity inched closer to answering the ultimate question. Are we alone? Elena returned to the control room, where the team was already planning the next observation. The James Webb Space Telescope had opened a window to the cosmos, and through it, they had glimpsed something extraordinary. Whether it was a bustling alien metropolis or a natural phenomenon, they didn't yet understand. The discovery had ignited a spark of hope. For the first time, humanity had a reason to believe that the stars might not be as lonely as they seemed. A new era of exploration. As the months passed, the Proxima B discovery became a catalyst for change. Funding poured into exoplanet research, and international collaborations sprang up to design the next generation of telescopes. Scientists dreamed of mapping distant worlds, analyzing their climates, and searching for biosignatures that could confirm the presence of life. The public, too, was captivated, with school children sketching alien landscapes and philosophers debating the ethics of contacting an extraterrestrial civilization. For Elena, the journey was just beginning. She spent long nights poring over data, refining models of Proxima B's atmosphere, and imagining what kind of beings might inhabit a world so different from Earth. Were they like us, gazing at their own night sky, wondering if they were alone? Or were they something entirely beyond human comprehension? The James Webb Space Telescope had given humanity a glimpse of the impossible, and now the race was on to uncover the truth. With every observation, every new technology, and every daring idea, the universe was revealing its secrets. And somewhere, for light years away, the lights of Proxima Centauri B continued to shine, a beacon of possibility in the vast cosmic night. The echoes of a distant world months after the initial discovery, the control room at NASA's Goddard Space Flight Center had become a second home for Dr. Elena Martinez. The once quiet space now buzzed with a constant stream of activity, astronomers, engineers, and data analysts working around the clock to decipher the enigmatic signals from Proxima Centauri B. The rhythmic pulses of light, detected by the James Webb Space Telescope, had not faded. If anything, they had grown more intriguing, revealing subtle variations that hinted at complexity beyond mere natural phenomena. Elena stood before a wall-sized screen, displaying a spectral analysis of the signals. The data was mesmerizing, sharp peaks in the infrared spectrum, pulsing at regular intervals, with faint secondary signatures that suggested multiple sources. She traced her finger along the graph, her mind wrestling with the possibilities. Could these be communication signals? Energy discharges from advanced technology? Or something we can't even fathom? Elena, we got new data from the latest observation run. Raj Patel called from across the room, his voice cutting through her thoughts. He gestured his monitor, where a 3D model of Proxima would be rotated slowly, its night side speckled with faint, glowing points. We've isolated at least a dozen distinct sources. They're clustered in a way that doesn't match any known geological activity. Elena across the room, her pulse quickening. The model showed a planet locked in an eternal dance with Proxima Centauri, one side blazing under the star's red glare, the other shrouded in darkness. The glowing points were concentrated in a band near the planet's terminator, the twilight zone where day met night. It was a region where temperatures might be moderate enough to support life, a sliver of habitability on